Hello everybody, Root Beer here, and I sincerely hope you're doing well. We're up to question 20 on our 2010 Fermat paper, so it's been quite a journey. We're at the end of part B now, and so up next will be part C where the questions are worth a little bit more. But what have we got here? A square has side length 5. In how many different locations can point X be placed so that the distances from X to the 4 sides of the square are 1, 2, 3, and 4? Okay. So side length 5, I notice 1 and 4 add up to 5, and 2 and 3 add up to 5. And I don't think there's sort of any other arrangement that we're going to get other than we're counting the points X, where X to one side is 1, X to the other side has to be 4, because in total we have a 5 up here, and X to this side is a 2, and X to this side is a 3. Now you might think we need to satisfy all these conditions, but the closest distance from X to any line is going to make a nice little right angle here. And if we think about it, yeah, all I really need to do is, so as soon as I place the 1, the 4 is the other length, the length to the opposite side. As soon as I get the X being a distance 2 away, the 3 is automatically sort of the opposite. So all I need to do is sort of pick a side and say, all right, that's the side X is going to be distance 1 away from. So X must lie along this line that is distance 1 away. And then I pick another adjacent side. So I've got 4 choices for this side, and then 2 choices for the adjacent side. And then once I make that choice, then that's sort of that'll be the one that I'm distance 2 away from. So X will have to lie somewhere on this line, and that uniquely determines where X is. So 4 choices for the side that you're 1 away from, 2 choices for an adjacent side that you're 2 away from. This is going to be 8 choices for X. This isn't the only way to see it. So let me explain my reasoning in a different way. If we look up here, and I use a little color, maybe the orange, I have a nice little orange rectangle of 1 by 2. Now, he's got to be placed in a corner, because it will always be a 1 by 2 rectangle. You can do this with a 3 by 1 or a 3 by 4, but the point is 1 and 2 will never form a line, those distances, because they don't add up to 5. So pick a corner, and then you can place the 2 by 1 rectangle in there. And as soon as you place it, that gives you an X, because it's going to be 4 to the other side and 3 to the other side. Now there's 4 corners you can place in. 1, 2, 3, 4. And then you have a choice of how do you arrange your rectangle. Okay, so here we're choosing the same corner, but we're laying the rectangle down slightly differently. But this still picks a good X point, one that we're interested in. So this is another way to count it. Pick the corner you put your rectangle in, and pick one of 2 ways to lay the rectangle down. And the corner opposite the square's corner is your X. So that's 8 in another way. Okay. So I really like this question. It didn't take as long as I thought it might. Certainly not as long as some of the other ones. Like 17 took me a little longer than I feel like it should have. But there we go. So we take a look. 0, 4, 8, 8. There it is. D. Okay. Now there's 12 and 16, but I'm fairly confident in the way we've gone through this, despite it being simpler than I would have expected for a question 20. So we're going to bubble in D8. And we're going to get ready for question number 21, starting off part C in the next video. So until then, take care.